done. Can you guys hear me? Am I audible? Can you tell me the formula of work done? Equal to force into displacement. Okay. Now, when you apply force, okay, then force is applied on a body. It will move obviously in the direction where you're applying the force. Okay, there is an energy transfer. Okay, because of which the body moves. So which body moves. Okay. What is the energy? Energy applied in physics. Okay. If you guys know the answer, please tell. Okay.
Which is required to do any work.
Energy is this is a standard. I think we have all learned this. It is a capacity to do work. What is the unit of work done?
Joule.
Yes. Okay. What about energy?
Same.
Same. Correct. So unit here is. Okay. Now again, let me remind you that this is for Nata. Okay, and we are just doing the basic brush up on physics because they have not yet asked you deep questions or problems on this. Okay, what are the types of energy? Yes, kinetic energy.
Potential energy.
Yeah, one more is potential energy. Correct. What is kinetic energy? Energy possessed by a body by virtue of its motion. Okay. Virtue of its motion. Okay. Now, what is the formula for the kinetic energy?
MGH.
That is partially correct for potential energy. This is because of motion. Okay, motion, what happens? There's velocity. So, kinetic energy is equal to half mv square. Okay, now energy obtained by an object, okay, by virtue of its motion. For example, if you're throwing a ball, okay, their motion is happening. That's why the object gathers the kinetic energy. Second one is potential energy. Okay. This is possessed by a body by virtue of its position. Okay. Okay. Now you have all seen dams, right? This is a very classic example of potential energy. Water that is collected behind a dam, okay, that has a flow with that has an energy in it, okay, because of its position. That is called the potential energy gathered in it. Okay, what is the formula of potential energy?
MV.
V is momentum, no, mgh.
MGH.
Yes, m, where m is the mass of the body, g is acceleration due to gravity, okay. H is the height where from the ground where it is being kept at, whatever objects. Okay, what is the value of acceleration due to gravity? Close to Earth is 9.8 meter per second square. What is the law of conservation of energy? Must have heard. Have you guys heard of it?
Yes, ma'am.
The law of conservation of energy says that the total energy in an isolated system remains constant. Okay, it can be converted from one form to another. Okay, but it cannot be created nor destroyed. Okay, this is one of the common conservation of energy, right? Energy will neither be created nor destroyed. Can be converted from one form to another. Can you give me an example where one form of energy is converted into another?
Mechanical to electric.
Mechanical to electrical motor. Yeah. Your batteries, your chargers, right? Batteries and all, they all contain chemical energy. Okay, that is converted into electrical energy. Any questions? Next, power. What is power?
What, ma'am?
What is power in physics? Okay, now I told you, no, what is work done? Energy transferred, correct. Now, the energy transferred, okay, or converted, as we were saying, per unit time. Okay, so unit okay. So P is written as, what is the formula of P? W by T. Okay, what energy transfer per unit time. Okay. What is the unit of SI unit of power?
World. World.
Yes. Okay. In in a system, okay, suppose two objects are there. What does collision mean?
What, ma'am?
What does collision mean? Even if you want generally also, what does collision mean?
Interact.
Collision means, two objects hitting each other, you can see, right? Now, in physics, okay, now there may be physical, physically they may collide with each other, or because of one path's, because of one object, another object's path may also change. Okay, so I'll tell you what it is. Between two objects occurs, they physically collide with each other, or if the path of one object is affected by the force by the other. Okay. Any questions till now?
No, ma'am.
Okay. Now, what is the meaning of optics? I think you have studied wave optics and ray optics. What is the meaning of optics? Optics is a study of light and how it changes its properties. Okay. Now, when light strikes an object, okay, matlab it hits an object, then what are the possible things that may happen to the light? It can get reflected, okay? It can get absorbed, right? Or it can get refracted,
Refract.
right? What does refracted mean?
Refract.
See here. Refraction is the bending of light when it passes from one medium to another. Okay. This property of refraction is used in a number of devices. Okay. This property itself is used in microscopes, magnifying lenses, corrective lenses, etc. Okay. So when light strikes an object, it either gets absorbed, reflected, and refracted. Now, what is reflection?
When
Generally speaking.
Change in direction of light.
Change in direction of light, kind of true. Okay. See, some objects are reflective surfaces where the light bounces back. Okay. So that is called reflection of light. I'm not saying ki where from where the ray has hit, in that direction only it will come, but it will bounce back. Okay.
Okay.
What are the examples of reflection of light? Very important, common example.
Plane mirror. Reflection of plane mirror.
Yes, in your mirror, okay, your light is reflected back. That's why you see your image. Okay. Now, refraction में
what?
it,
A glass of what?
yeah, bending of light. Basically, refraction means bending of light. Okay. Now, in the same object, some of the light may get reflected, some of the light may get absorbed, some of the light may get refracted. Okay. This is not just for this is a very
Can
good.
you explain TIR once again?
I've not explained it.
Okay, okay. Yeah.
Okay, this is a good movie. Okay, this is a good example for refraction of light. Okay, air to glass to air. Okay, the bending of light that happens is called refraction. Okay, now what is total internal reflection? TIR.
When critical incident is greater than 90 degree and the ray does not enter into rarer medium, but it enters into the denser medium.
When a beam of light strikes an object, light is completely reflected. Okay, this phenomenon is called total internal reflection. Now, what you said about angle of incidence, that or not? Yes, true, very true. We'll see that. Okay. What is dispersion?
Light dis-
Hmm? What does dispersion word itself mean?
splitting of light.
Yes, fleeting.
Colored rays of light coming from a prism.
You know, essentially true, but not quite. But it doesn't explain the why. Okay. It is a property of light where white light, okay, that passes through a prism usually, it splits into its constituent colors. Okay, white color is made up of 7 colors, which are rainbow,
Vibgyor.
Rudgyat. So those and all colors are split. Do you guys know about Newton's experiment? Like it was a simple experiment. He made a color wheel which had all 7 colors. Okay, when you rotated it very fast, okay, you could see it becoming a white color because of its rapid the combination of all these. Okay, now to disperse this light, okay, or meaning splitting the light rays or converging them. Okay, what is a device that is commonly used?
Can you repeat it once again, please?
What about
The question you asked
okay, the
something.
question. What is
Yeah.
the device used, generally most usually used to converge or disperse a light beam,
A prism.
prism, and
Stop.
lens? Okay. Lens is an optical device used to focus or disperse a light because of refraction. Okay. What are the types of lenses?
Convex lens and concave lens.
Convex lens and concave lens. Okay. What is a convex lens? A converging lens which will cause the light rays to bend to a specific focal point. Okay, another name for this type of lens is a positive lens. Light rays, okay, by passing through this medium, okay, they get refracted, meaning they bend, okay, and converge into one focal point. A point, it's called a focal point. Okay, this is called a convex lens. Okay, what is the other type of lens?
Concave.
Concave lens, also called a diverging lens, okay, which causes the light rays from a specific focal point to spread out. Okay. Another name for this type of lens is a negative lens. Okay. Let's see some uses of convex lens. The most common use of convex lens is in a magnifying glass. Okay. Magnifying glass, where you have to, all the rays, okay, should focus on a specific focal point, okay, at the center. Convex lens in eyeglasses. I think this is one of the most common use of lens. Okay, it is used in your spectacles. A person can have problems like far-sightedness or nearsightedness. What is far-sightedness? What is far-sightedness? Yeah.
Far object.
It's
It is
myopia and we can't see far objects.
yes, hyperopia. Nearsightedness might be. Farsightedness basically means what it says. Farsighted means you can see far-sighted objects. Nearby objects, right? They look blurry. Okay, nearsightedness is the opposite of it. You can see near objects but not far objects. Okay? Person can have problems like farsightedness or nearsightedness as the eye lens fails to focus the light on retina properly. Okay, person who is suffering from farsightedness, the image formed by the lens is far behind the retina. Okay. Convex lens in cameras. In cameras, we use a convex lens because it focuses on an image as well as magnifies it. Okay. Also, the camera lens consists of a convex lens followed by a concave lens. What does this mean? Followed by a second convex lens. In a camera, they use convex lens and a concave lens. Okay. Convex lens in microscope. This is again one of the most common uses. It helps to magnify small objects, okay, and observe them. More simple microscopes mostly consist of 3 lenses. Okay. So where are the what is it? Convex lenses used? In microscopes, cameras, okay, in eyeglasses. Yes. Can you guys see the screen?
Yes.
Magnifying glass. This is the use of concave. Binoculars and telescopes use convex lenses to magnify objects, okay, and make them appear closer. But convex lenses don't transfer light accurately. They create distortions and blurs. So binoculars and telescopes install concave lenses in or before the eyepieces to help focus the image more. Okay, so concave lenses are used in binoculars and telescopes. Okay, glasses, eyeglasses. Opticians use concave lens to correct nearsightedness, also called myopia. A nearsighted eyeball is too long. Okay, concave lenses in glasses correct this by shortfall of spreading out light. Okay, so they use concave lenses. Cameras. Okay, cameras again, as we saw before, there is a convex lens followed by a concave, then again a convex. Flashlights.
Hello, ma'am.
Yeah.
Hello, ma'am. Hello, ma'am. Hello, ma'am.
Yeah.
Good night. Hello.
What's happening? Okay. Flashlights. Concave lens are used on flashlights to magnify the light produced by the bulb. Okay, obviously, if you see a flashlight, okay, it disperses the light, it spreads the light out. Okay, they're concave lenses. Okay. Lasers. Various types of medical equipment, scanners, and CD players use laser beams because these are highly focused. Okay, they must often be dispersed in order for the equipment to work properly. Small concave lenses can widen a laser beam to precisely access a specific area. Okay. Peepholes. Peepholes are the ones installed in your door. So these are obviously, if you can imagine it, okay, it is from a small point to a wider range. Okay. Door viewers or peepholes are small security devices. Okay. The view is created through one or more concave lenses inside the device, which minimizes the proportion of specific objects and gives a wide overview of an entire area. Okay. Any question? Oh. Okay, sir, you can end the session.